So the next question. A photon is emitted from an atom with an energy of 4.25 times 10 to the 19th power joule. Negative 19th power joule. What is the wavelength of photon? Okay. So we would first write out energy. So E equals hv. And then here, now C equals lambda v. Okay. C is the speed of light. And so because we want to find the wavelength, we would have to somehow put in lambda in here. So we can do V equals C over lambda. So lambda is the wavelength. Okay. So E equals hc lambda. And since we know that E equals 4.25 times 10 to the negative 19th power, we'll write that 4.25 times 10 to the negative 19th power equals lambda. H is Planck's constant, which is 6.626 times 10 to the negative 34 power, I think. Yeah, so Planck's constant is 6.626 times 10 to the negative 34 power. And c is the speed of light, and that would be we would just write okay, we don't really have space there, so we would just I'll just take the highlighted thing and then just say 3 times 10 to the 8th power. It's like 299,792,458 meters per second, but we don't really have to be that specific. So that would mean that we want to, so we have to get lambda. Okay, so lambda equals this, so that divided by that. Okay, so lambda equals, I'll just do it in my calculator, 6.626 times 10 to the negative 34th power times 3 times 10 to the 8th power, and then divide that by 2.25 divided by 10 to the negative 19th power, and That should be alright. Okay. Oh, I put the wrong number in. Okay. Divided by 4.25 divided by 10 to the negative 19th power. So that's 4.677176647 times 10 to the negative 7th power meters. Okay, and since nanometers are, since 1 meter, no, is it? Is 1 times 10 to the negative 9th. No, it's the opposite. 1 times 10 to the negative 9th power meter equals 1 nanometer. Okay. I'm pretty sure that's correct. Okay. So, if we want to change that, we would write, since there is no such number, we would want to write it, we would want to change it to nanometers to check if this number is about 468 nanometers. Okay, so if we want to convert it to nanometers, we'll just simply divide that by 10 to the negative 9th power. Okay, so that would equal 4.677176647 times 10 to the 2nd power nanometers, and that's equals 467.717647 nanometers. So if we just round that to the whole number, we'll get 468 nanometers, which is the second one. So our wavelength of the photon would be 468 nanometers.